Hey guys, in this video we're going to be covering Target 2B.3, and our mastery learning objective is being able to raise polynomials to a power by expanding the expression to repeated multiplication. So kind of a recap just so that we remember, if we had x to the fourth, that exponent there, which is a 4, tells you how many times you need to multiply the base by itself, right? So 4, we are multiplying x times itself 4 times. That's exactly what we're going to be doing, except for we might have a little bit more than just one term as our base. We might have a binomial or a trinomial. So looking at our first example, quantity of x minus 5 squared. All this means is x minus 5 times the base one more time, right? So we see that power of 2. Therefore, we're going to multiply the base by itself 2 times. Exactly what we were doing yesterday, or in the previous video, with our polynomial. So this is a 2-term binomial, and that is a 2-term binomial. So therefore, if I'm multiplying, I'm going to use my Punnett square box. Right? X minus 5, x minus 5, and I can go ahead and multiply all of those together. So x times x squared, right? Each of these have a power of 1. Next term, x times a negative 5 is a negative 5x. X times a negative 5 is a negative 5x. And negative 5 times negative 5 is a positive 25. I'm writing my terms out. Final answer. You see that I have my x squared there. So x squared, I have my negative 5x and negative 5x. Those are my terms. Right? Negative 5x and a negative 5x is a negative 10x. And my last term is a positive 25. Right? There's no other constant. So therefore my positive 25 just gets dropped. Again, remember in order from greatest to least exponent as well as alphabetical. Looking at example B. Same thing, we have the quantity of y plus 3 squared. We see that exponent of a 2, so therefore that is going to tell me I am multiplying the base by itself 2 times. So all this changes into is the quantity of y plus 3 times the quantity of y plus 3. We are multiplying, so we could use our Punnett square box. It is a binomial times a binomial, so I know I'm going to be using a 2 by 2. Y plus 3, a y plus 3. And we can go ahead and multiply. Y to the first power times y to the first power is y squared. Remember, when we multiply, we added exponents. Y times 3y is positive 3y. Y times 3y is another positive 3y. And 3 times 3 is a positive 9. Alright, again, we're multiplying. We can combine our like terms. So I see my y squared right there. My diagonals, 3y and 3i, are common terms, right? Like terms there. So we can go ahead and combine those. 3y plus 3y is 6y. In my last term, I have that constant of 9 that has no other like terms. So I just bring that down to my final answer as a positive 9. And moving on to our next example here. I'm going to scroll down. We see something like the quantity of m plus n quantity squared. Now, there are no numbers here. We have just variables, but it means the same thing. We see that exponent of a 2, so all that's telling me is multiply that base 2 times, right, by itself. And one thing that we have to be careful with is when we multiply our variables, they always are written in alphabetical order. So I'm going to draw my Punnett square box and have a binomial times a binomial. And n, positive m and a positive n. And then we multiply. M times m. Each of these had a power of 1, so therefore this is Now when we multiply m times n, we always write those variables in alphabetical order. So I'm going to go ahead and write, make sure you guys remember that. Right? Variables always written in alphabetical order. Alright? So, next term, m times n, again, alphabetical order. M comes before n. N times n, well, this is n to the first, this is n to the first, so this is going to be n squared. Writing out all my terms in alphabetical order, I see an m squared. I see two mn's. Right, so each of these have that coefficient on a 1, so 1 plus 1 is 2mn. And our last term is n squared. We're moving on to our next example, letter D. Quantity of 2x minus 3y squared. Again, all this means is we are multiplying that base 2 times, right? Multiplying it by itself however many times our exponent tells us to. Then we have a trinomial, not a trinomial, my bad, a binomial, because each of these have 2 terms in each. So it's a binomial, so 2 by 2. 2x minus 3y, 2x minus 3y. Make sure you keep each binomial on its own side, and then we multiply. 2x times 2x is 4x squared. Remembering those x's have a exponent of a 1, so we add those together. 2x times a negative 3y. So 2 times a negative 3 is a negative 6. X times y is just xy. Again, remember alphabetical order. Next one, 2x times a negative 3y. 2 times negative 3 is a negative 6. X times y, xy in alphabetical order. Last one, negative 3y times a negative 3y is a positive 9y squared, because those y's had those coefficients of a 1, so we add those together. Alright, writing our like terms out, I have my 4x squared. I have my diagonals have the same term. They are both xy's. So those are like terms, and I can combine those together. Negative 6 and a negative 6 is a negative 12. Leave my variable of xy alone. And then my last term is a positive 9y squared. So I bring that down, positive 9y squared. Alright, moving down to example E. We see that we have the quantity of c plus 4 raised to the third power. So this third power here tells us that exponent, we need to multiply our base 3 times. So c plus 4 times c plus 4 times c plus 4. Right? And one thing to remember that when you have a trinomial, right, we're multiplying 3 things, only do 2 at a time. Right? Only 2 at a time. Right? So I'm only going to be looking at these first 2. Alright, so I'm going to bring that down and say, well, I'm going to have a binomial times a binomial. So c plus 4 and c plus 4. I'm going to multiply all of these out. So c times c, c squared. 4 times c, positive 4c. 4 times c, positive 4c. 4 times 4, positive 16. I'm going to go ahead and combine my like terms, and I'm going to get c squared. 4c and 4c is a positive 8c. Right, that came from my diagonal right there. And then I have a positive 16. Now we're not done yet because that was just the first two binomials, right? So I'm going to go ahead and put that in parentheses, and don't forget to bring down my other c plus 4. Right, that was still part of our equation that I forgot. Not forgot, but we just can only multiply 2 at a time. Now we have to multiply it one more time. I have a trinomial, right, 3 terms, by a binomial, which is only 2 terms. So I'm going to have to write a 2 by 3. Right, my c squared, my positive 8c, and my positive 16. On the left side, I'm going to have my c plus 4. Right, multiply all of these terms together. C squared times c to the first. I'm going to add those exponents to be c cubed. 8c times c to the first. Well, there is that invisible coefficient of a 1 in front of that. So 8 times 1 is 8. C to the first times c to the first is c squared. I add the exponents. 16 times 1c is 16c. 4 times c squared is 4c squared. 8c times 4, well 8 times 4 is 32c. 16 times 4 is 64. Alright, looking at all my terms now, I'm going to combine them as I write them out. So I have my c cubed. I see my x, my diagonals again, right? C squared and c squared. 4 plus 8 is going to give me a positive 12c squared. Going in order 2 by highest degree. Last diagonal here, I got 32c and a 16c. Added together will give me a 48c. And my last term, 64, there's no other constants, so plus 64 at the end. I have to scroll up just a tad bit to look at our last example. But actually, I'm just going to have you move on to our homework, so we can actually just skip F, and you can work on activity 2B.3.